let's say you have a table of densities, and so you know the density of zinc is a certain amount. If you calculated the density of a zinc cylinder to be a slightly different amount, what would be your percent error to correct significant? What would be your percent error to correct significant figures? All right, so percent error. So you might not be accustomed to seeing the absolute value sign outside of percent error, but then you might also have your E in front of your A. Here, A, I made that for actual, so the actual density, and E is experimental, and experimental is what you did. It's what you measured. And the reason the absolute value sign's there is because basically whichever the bigger number is what you put first. And you always divide it by E. Okay, so for us, I'm going to do like I normally do. Actual is 7.13 grams per centimeter cubed, and that is because that's what we found in the table. Experimental is what we did. We might have made a mistake. 7.89 grams per centimeter cubed. So I've got 7.13 grams per centimeter cubed minus 7.89 grams per centimeter cubed divided by my 7.89 grams per centimeter cubed, and then all times 100. Oh yeah, and we take the absolute value of that. Because 7.13 is less than 7.89, so we'll get a negative number. When we divide a negative number by a positive number, we'll get a negative number. When we multiply our negative number by our positive number, we'll still get a negative number. And percent error shouldn't be negative. So that's why they said we'll slap some absolute value signs around there. So no matter what, it'll be positive. So I am going to stick this in the calculator. 7.13 minus 7.89. And I get a negative 0.76, but we know that's a positive 0.76. So 0.76 divided by 7.89, I get a 0.096, blah, blah, blah. I'm going to go ahead and multiply that by 100. Aw, crap. I just minimized my window. Okay, multiply that by 100, and I get 9.632446,134%. Sig fig time. Okay, we're not going to use our actual because that came from the table, but we are going to use our experimental, and that's 3 sig figs. So 1, 2, 3. That 3 is going to stay at 3 because the number to the right of it is a 1, 2, 3, or 4. So that is 9.63% error. Don't forget, go to settings to alter the playback speed if you need to slow me down, and I'll see you in the next video.